It's time to jump into Python Lambda functions, those neat anonymous one-liners that can make your code more concise or leave you scratching your head when debugging. By the end of this video, you'll know exactly what lambdas are, where they shine, and when you're better off reaching for a regular function. At its simplest, a lambda function is just a quick way to define a function without naming it. They're declared with the lambda keyword followed by any arguments, and lastly, an expression. Lambdas only allow a single expression, so they're perfect for small, inline operations. Here's a quick example of how you would add two numbers using a lambda function. With this, Python gives you back a function object that adds two numbers. No def, no multi-line boilerplate. Python values readability, so you might wonder why it includes this shorthand. The answer? Sometimes brevity is clarity. When you need a tiny function for a one-off operation, especially inside another call, Lambda keeps your code focused. It's not meant to replace def. It's just a handy shortcut when the function's logic is short and obvious. For example, here we've got two functions which both help in formatting usernames. This works fine, but the clean username function is now floating around your module, even though it's only relevant to one place. It's unlikely to be used anywhere else, which means it pollutes the namespace and breaks locality of logic. Not terrible, but unnecessary for one-liners. Now, if we turn this into a lambda function, we keep things short and concise, without the need for a separate name function which we're unlikely to use again. Since lambda functions are anonymous and don't have names, debugging our code can often be more difficult because tracebacks aren't able to reference a specific lambda function using a name. What do I mean by this? Well, take a look at this code where we've got a regular function which adds two variables, followed by the same function implemented as a lambda. When we print the name of each function, we see that only the regular function has a name. The lambda version just prints out a generic lambda as the name. This means if we run into an error in our code, looking for specific lambda function names in the traceback isn't going to help very much. In this case, we'll often need to rely on line numbers and stepping through our code in a debugger. In Python, all functions, named or anonymous, are first-class citizens. This means we can assign lambda functions to variables, just like we're doing here, even though this is generally discouraged. If you're assigning a lambda to a variable, a regular function is usually the way to go. We can also pass lambda functions as arguments to other functions like we're doing here. In this case, map accepts a function as the first argument, and an iterable as the second one. It might look a little strange, but this is perfectly valid and proves that lambda functions can be passed around just like you would any other variable. Lastly, we can also return lambda expressions from functions, which is another property of first-class citizens in Python. In this example, by returning a lambda function, we've created what's called a closure. Closures and factory functions are a bit more of an advanced topic. If you're keen to learn more about them, there's an article linked below. Lambdas really shine when paired with higher-order functions. In a nutshell, higher-order functions are where a function is accepted as an argument, or where a function is returned as a result. In Python, map, filter, and sorted are all higher-order functions. Map, which we've already seen, applies a function to every element in an iterable. To do this, it accepts a function as the first argument, which is then called for every item in the second argument. So in this case, every item in the numbers list is passed to the lambda function, which raises the number to the power of 2. Next up, we've got filter, which follows the same pattern of accepting a function and an iterable. Filter returns only the elements that meet a certain condition. Again, this logic is compact and clear in one line, which is a great use for a lambda. Then we've got sorted, which is perfect for when you want to sort something by a specific rule. It's another great use case for lambda expressions. In this example, instead of sorting alphabetically, this sorts the list by word length, shortest to longest. These are all classic lambda-friendly situations. Time for a few real-world use cases where lambda functions are a perfect fit. First up, we've got this user's dictionary containing names and scores. Our goal is to sort the dictionary by score. For this, we use the sorted function by passing in the user's dictionary as the first argument. Then for the key, we pass in a lambda function which returns the score for each user. This allows us to sort the dictionary based on the score of each user. Pretty neat. Next, we've got this list of products where our goal is to create a new list which only includes products which are on sale. For this, we use the filter function and pass in a lambda function as the first argument. The lambda receives a name and then returns true if the word sale is in the name. In the second argument, we pass in the list of products. This means that each product in the products list is checked to see if the word sale appears, and if so, it is included in the final list. That's your quick guide to Python Lambda functions. They're small, powerful, and best when kept simple. If this helped you out, Give it a like, subscribe for more Python tips, and check the links below for the full blog post which covers Lambda functions in more detail.